Assalamualaikum warahmatullahi wabarakatuh. My name is Nick of phone Malaysia. Register number 20095, and this is our product showcase for integrated design project PE40803 for this semester. We are from Smart Agriculture 15, and we are supervised by Puan Merah Binti Abdul Rahman. Our project title is LoRa Enables Smart Agriculture System for Real-Time Monitoring in Tapioca Cultivation. Next, this is our group member. First group member, as the leader of the group, myself, Nick Muhammad Afwan bin Rizal. Next, second group member, Shahrizal bin Arifin. Third group member, Sharmila anak perempuan Sudar. And last, our group member is Sharmina anak perempuan Unggad.
Agriculture is crucial for food security and economic growth. As per demand for food grows, technology becomes essential to modernize the farming practices. LoRa, which is called as long-range communication technology, plays an important role in transformation by offering a low-power, wide-area communication, which is actually useful in rural areas. Rural areas, there's no Wi-Fi or other infrastructure. LoRa enables devices to communicate over long distance with minimal energy consumption. So in these remote areas where reliable internet is unavailable, LoRa can actually provide efficient wireless communication. And where it is paired with IoT sensors, it will allow the farmers to collect data on vital environment such as temperature, soil moisture, humidity, which will help to optimize the crop management. Cassava cultivation. It also face challenges in remote locations where plantations are difficult to monitor. Farmers usually struggle with managing conditions such as soil moisture and also the temperature. It will lead to issues like over-irrigation and suboptimal crop. So without this real-time data, traditional farming methods often fall short in these areas. So the key issue here is the lack of affordable real-time monitoring solution for tapioca fields in remote areas. This study aims to develop a LoRa-enabled IoT system to enable the remote monitoring of tapioca plantation. We will focus more on parameters like soil moisture, soil temperature, ambient temperature, and also the humidity. The goal is to actually help the farmers make better decisions, optimize irrigation, and improve yields whilst supporting the sustainable farming practice.
Assalamualaikum and hello, my name is Shahrizal. So now I present to you our problem statement. So the first one is difficulty in monitoring cassava plants due to the farm's remote location, leading to delays in timely observation and care. And the next one is environmental conditions such as soil moisture, temperature and humidity are challenging to analyze effectively, limiting opportunities to optimize cassava growth and yield. And so for the next one is objective. So we have two objectives. The first one is to develop a monitoring system using IoT which can monitor the plant remotely. And the next one is to monitor the parameter of cassava plantation environment using variation of sensors such as we use humidity, soil moisture and many others sensor. So that's it. So that is steep analysis. So for the social is wireless sensor LoRa technology boosts farming efficiency and sustainability, supporting healthier crops and meeting the demand for organic sustainable food as the population grows. So next is technological. So WSNs and LoRa technology enable real-time soil monitoring, reducing manual checks and improving resource efficiency to boost farm productivity. And for the environmental, these technologies optimize water and fertilizer use, reducing waste and environmental impact while supporting eco-friendly, sustainable farming. And for the economy, despite setup costs, WSNs and LoRa sensors save money long-term by reducing resource use, boosting yield, lowering farming costs, and supporting agriculture growth. And for the last one, which is political, government support LoBSN and LoRa sensor to enhance food security and sustainability, subsidize and policy encourage farmers, especially in rural areas, to adopt these modern tools. So that's it for the sleep analysis. Thank you.
My name is Shadbina. So for the next part, I will be explaining the schematic circuit diagram for the transmitter side. So on the transmitter side, we are using Arduino Nano board and also LoRa module, which is SX1278. The reason we are using LoRa module is because since it's a rural area and has no Wi-Fi signal, so we can't monitor the data or control the device over the internet. So that is why we are using the LoRa module. And the LoRa module also has a frequency of 433 megahertz, and this module we interface it with multiple sensors like capacitive soil moisture sensor, which is used to measure the quantity of water present in the soil. And we also use the DS18B20 waterproof temperature sensor to measure the temperature of the soil. And apart from that, we also use THT22 temperature and humidity sensor, which is used to measure the temperature and humidity of the surrounding. And also we use 5-volt single channel relay module to control the water pump, and as well as the DC water pump itself, which is used for automatic irrigation system. And the reason we are using this LoRa transmitter module is to send the parameters like relative humidity of soil temperature, relative humidity and temperature of surrounding wirelessly to the LoRa receiver. So this is the schematic circuit for the receiver side. So on the receiver side, we have connected the LoRa module to the Node MCU ESP8266 Wi-Fi module because it has a built-in Wi-Fi chip, so that the LoRa module receives the data and the ESP8266. The board will upload this parameter to the IoT server. And on the left hand side of the diagram, we have the connection table between the LoRa module and also the Node MCU ESP8266.
In this demonstration video, we will show you the system which has two sides. First, the transmitter side has the components such as Arduino system controller, LoRa transmitter, water pump relay that will connect to the water pump. Next, we have the HD22 that measure the surrounding temperature. We also use the S18B20 for soil temperature. Lastly, we use the capacitive soil moisture sensor. At the receiver side, we use SP8266 that will connect to the Wi-Fi and link application, and LoRa receiver to receive all the data from the transmitter side. So this is how the system works for monitoring. We start with setting up all the sensors to soil and close to the Topiaca plant. For the first demonstration, we put the transmitter and receiver side close to each other. So after we switch on the system, we will receive the data such as soil moisture, soil temperature, surrounding temperature, and humidity in the big application, either on the computer or in the phone. Next, we try to get the data of the job plan. For the second demonstration, we put the distance between transmitter and receiver side with the distance of 200 meters. As the result in the big application, we found that uh, we can still have data to the big application. So that's all for the